Hello, I'm Sid Shah from the Low Power RF Connectivity Business in the Wireless Business Unit of TI. Today I will be talking to you about two low power RF protocols, Bluetooth Low Energy and ANT. During this talk, we will cover the basics of Bluetooth Low Energy and ANT from a technology perspective and discuss the latest applications, market trends, state of the union, and TI's involvement and offering. We will also then briefly compare the two technologies. During the course of the session, please feel free to post your questions in the chat forum and they will be answered in order. With that, let's jump into the Bluetooth Low Energy discussion. In July of 2010, the Bluetooth SIG announced the latest spec version of the Bluetooth spec as of today, called Bluetooth 4.0. The biggest addition in this spec was the introduction of the Bluetooth Low Energy protocol. There are two types of devices for Bluetooth Low Energy: single mode devices that support only low energy, and dual mode devices which support traditional Bluetooth plus low energy. The single mode low energy devices are primarily targeted for low power applications and you can run these products on coin cells. As discussed, on this slide you see a few examples of applications for each type of Bluetooth devices. On the rightmost columns, you see the traditional Bluetooth devices. On the left in the center, you see the newer Bluetooth devices based on single and dual mode. On the single mode side, most devices that have stringent power and size requirements and need to run on a coin cell are listed. These include sports and fitness equipment sensors, wireless keyboard and mouse peripherals, as well as medical and proximity-based sensors. On the dual mode side, you see applications that need to run both low energy to communicate to these sensors as well as Bluetooth for higher data and throughput requiring applications, such as smartphones, laptops, and tablets. Let's now touch briefly on the characteristics of BLE. This technology is best suited for low bandwidth devices that transmit periodically or infrequently. The maximum throughput at the application level is about 100 kilobits per second. However, most use cases for BLE are around 10 to 30 kilobits per second. As discussed earlier, BLE is not compatible with existing Bluetooth devices that are not Bluetooth 4.0. However, most traditional Bluetooth devices based on previous Bluetooth specs are working in parallel to upgrade their devices to support Bluetooth 4.0. Bluetooth Low Energy has much lower power than traditional Bluetooth. Later in this presentation, we will talk in more details about power consumptions and power calculators. From a sky level, Bluetooth Low Energy power consumption is about 1/10 that of traditional Bluetooth. Device lifetimes are very much based on roles and communication intervals that you can configure for your application. As an example, the CC2540, which is TI's single-mode Bluetooth LE chip, configured in a slave role with a transmission interval of 1 second, will draw about 30 microamps, giving you a battery life of slightly over an year when powered with a traditional CR2032 coin cell battery. With the introduction of such low-power protocols, numerous devices that could never imagine being wireless are now being considered to switch to BLE for their wireless connection, primarily due to the small size, low power, and low cost solution. Often the question arises whether BLE is what one needs. If connectivity with millions of smartphones, laptops, and Bluetooth-enabled devices is attractive to one's application, then BLE is a wise choice. Let's briefly touch on the immediate market segments where BLE is making an impact. These include mobile phones, laptops, automobile accessories. On the dual mode side, sports, leisure, and medical equipment who have already been using proprietary low-power wireless applications are now considering BLE for the ecosystem advantage. These are on the single mode side. Gaming, HID, and remote controls are also considering BLE. And last but not the least is our proximity-based applications for security and spatial awareness. In fact, proximity products based on BLE powered by TI's 2540 are already available in the marketplace today. This is a marketing slide from the Bluetooth SIG, visually demonstrating what most research studies have shown today, which is as dual mode devices become the norm in cell phones and classic Bluetooth devices, the sensor market space around BLE will simply exponentially grow. TI, being involved in supporting solutions for both dual and single mode, gives us a unique advantage to not only deliver an extremely robust and mature BLE solution, but also puts us in a situation where we can help the Bluetooth Low Energy ecosystem by making early connections and partnerships between dual and single mode manufacturers. This slide is also from the Bluetooth SIG, showing how they structure their working groups. Bluetooth SIG, being an open alliance, has defined several different working groups, and TI is an active participant in most of the relevant working groups to help realize our customers' needs, deliver robust and mature first-to-market solutions, as well as help the BLE ecosystem in general. We will talk about BLE profile support and TI profile strategy in the coming slides. Let's have a quick visual look into what the immediate BLE ecosystem could look like in the near future. In the center, you have a dual mode enabled low energy device, which is probably going to be a cell phone, tablet, or a laptop. Around it, you have all the sensor markets seamlessly connecting and transferring data. You have the sports sensors, the home sensors, location and proximity, BLE HID-based applications, medical, and call ID alerts. These are just some of the near-term ones, and more application usages are being defined as we speak. Here's a quick technical comparison between Bluetooth and BLE. As you can see, most of the items such as packet length, packet size, RF channel, data rates are much smaller compared to Bluetooth. Since BLE supports only star topology, let's quickly take a look at one connection advertising scenario. Here you have two different master devices scanning. On the bottom center, you have a slave device transmitting to both masters. As one master device sends a connection request to the slave device, the slave then directly connects to that particular master device. Slave latency is one of many parameters that can be configured in your application. Generally, slave device sleeps during connection interval if no data is to be sent. However, if the slave latency is on, the slave device can skip end connection events and only wake up if it has data to send. This tremendously helps to reduce overall power consumption. If the slave latency is defined as off, the slave device will respond with empty packets every connection interval. Current state of the union of Bluetooth Low Energy. As I mentioned earlier, Bluetooth SIG adopted Bluetooth 4.0 and introduced Bluetooth Low Energy in July 2000. TI introduced the first single-mode silicon for Bluetooth Low Energy, namely CC2540, in September 2010. This solution is fully certified, and hardware and software kits and collateral have been available on the web at ti.com/BLE. Since then, we have continued to invest in BLE from both a SIG, hardware, and software standpoint. We are active participants in numerous working groups in the Bluetooth SIG, working on specifying use cases to further BLE and helping our customers realize their needs. We have recently launched our latest BLE software, which includes additional features such as supporting simultaneous connections and being able to be configured as master or slave device. In addition, we have released a comprehensive set of profiles and sample applications which help realize and speed up product development for our customers. We will discuss these features and profiles shortly. In addition to the software, we have also continued to invest in hardware improvements for the CC2540. The next generation of our BLE chip is CC2541, which releases in fourth quarter of this year, reaching extremely low power consumptions. On the dual mode side, without naming any customers, we see that the first smartphones enabled with Bluetooth Low Energy will be hitting the market in fourth quarter 2011 as well, in addition to the laptops and tablets. Let's take a quick look at the features and benefits of CC2540. The CC2540 is a true one-chip integrated solution aiming at low cost and size. It is a system on chip providing a complete solution including IC, protocol stack, profile support, and sample applications. TI also provides a network processor version of the BLE chip. The CC2540 comes with excellent RF performance, providing a link budget of up to -98 dB. In addition, accurate digital RSSI readings are available as well. The ultra-low power consumption allows for devices to run on coin cells for longer than a year depending on the application. The BLE stack is fully certified and has undergone comprehensive testing against dual mode as well as other single mode devices. Let's briefly look at the CC2540 from a hardware standpoint. The 2540 runs on an 8051 MCU and comes in two flavors, 128 and 256 kilobytes, with an 8 kilobyte SRAM. In terms of digital peripherals, 21 GPIOs are available and 2 USARs, UART or SPI, a full-speed USB 2.0, as well as two 16-bit and 8-bit timers are included, and built-in 128-bit AES encryption-decryption in the hardware. The CC2541 replaces the USB with the I2C. The size of the chip is a 6x6 QFN package. The CC2540 is also pin compatible with other low-power devices in TI, such as the CC2530 Zigbee, the CC2533 doing RF4CE, as well as the CC2541, which is the next generation of the 2540 BLE chip. BLE profiles. This has been a topic of interest for all BLE customers and more. Without certified profiles, product manufacturers who want to have their application talk to other Bluetooth 4.0 devices such as smartphones or laptops that they do not manufacture is not possible. Hence, availability of certified profiles is critical to most. TI's strategy to help our customers bring their product to market faster has been to identify the profiles that are of the most interest and then actively participate in the working groups of Bluetooth SIG to help specify them. In parallel, we do implement the profile up to the spec level and continue to finish it based on our proprietary implementation to make it available to our customers to start designing and testing their application today. Of course, in parallel, we continue to work in the SIG to push these to completion. As soon as a profile is certified by the SIG, TI will make a certified profile available shortly after. Below are the list of profiles that we just released as a part of our latest BLE software release. These include proximity, find me, HID, health thermometer, heart rate sensor, network availability, time, alert notification, and battery status. TI launched its first BLE mini dev kit back in September 2010, and this has tremendously helped the BLE ecosystem in general. The kit is priced low at $99 and comes with all the hardware and software necessary to build a BLE link and get started with development. The contents of the kit include a debugger, which works with the key fob as well as a USB dongle, supporting IAR and TI Flash Programmer, has a CC2540 key fob, which is powered by a CR2032 coin cell battery and has LED buttons, buzzer, and an accelerometer. This can usually be acting as a peripheral application or a slave device. Also included in the kit is a USB dongle, which acts as a master device. In the absence of dual-mode phones in the market with supporting BLE, this USB dongle has acted as a central device and has tremendously helped our customers realize their applications from a testing and designing perspective. Also included in the kit are our royalty-free entire stack libraries, fully qualified, a B-tool application which drives the USB dongle with HCI commands, scans for devices, connects, authenticates, and logs messages, a smart RF flash programmer which can flash the 2540. Also included is an IRL compiler with a 30-day free evaluation. In addition to that, a TI RF sniffer is included for free, which works with the mini USB dongle. Sample applications for all the profiles that we just talked about are also included, as well as power calculation application notes. A new part has been introduced by the TI Power Management team called the TPS62730. This is a 100 mA DC to DC solution with a bypass mode. The CC2540 plus TPS62730 combined together increase the battery life up to 20% on the single CR22 coin cell, 2032 coin cell. Reduced TX and RX current is one of the biggest features by including the TPS62730 device with the 2540. It uses ultra low power bypass modes current to support the sleep and low power modes. Comes in a small packet size of 1 mm by 1.5 mm QFN. The application notes and reference design for this part can be found in the link below mentioned in the bottom of the slide. This device is ideal for RF applications due to the excellent low power voltage ripple. CC2540 has been named the best low-power Bluetooth solution by several organizations. The link below shows a detailed comparison done by eEngineers.net, while awarding CC2540 the best low-power Bluetooth low-energy solution in CES 2011. In addition, the CC2540 Mini Kit and Stack are the preferred training platform for the Bluetooth SIG, whose training program called Atlas runs the Bluetooth low-energy trainings around the world. The CC2540 is also provided as a module. We work with multiple module providers in all geographies to help provide a BLE-enabled module. Below you can find a list of customers and links to their BLE-based modules. Once again, TI is the title sponsor of the Bluetooth Innovation World Cup 2011, which is run by the Bluetooth SIG, spanning from 1st of May to 15th of September of this year. TI does offer a 50% discount on the development kits to the developers who submit prototypes for their competition. This brings the Bluetooth Low Energy session to an end, and we will now go into the ANT section of this presentation. ANT, similar to BLE, is a 2.4 GHz wireless sensor network protocol. It is an ultra-low power protocol on both master and slave with extremely low development cost. ANT is on its third generation of products and is extremely mature and robust solution. ANT protocol and device are very simple and easy to integrate, thereby allowing for fast time to market. It does support complex network topologies, which makes it very unique. Also, the ANT-FS file sharing, which is a development of a specific file format called FIT, enabling fast file storage and transfers, making them ideal for numerous market segments. ANT has an install base of about 15 million nodes to date, and all these nodes are interoperable with one another. A quick history of ANT. It's important to note that unlike Bluetooth Low Energy, ANT is a proprietary wireless protocol. Let's quickly go over the history of ANT. ANT is owned by Dynastream Incorporated, which developed their first ANT product with Sunto in 2004. The first ANT chip was released in 2005. Dynastream then got purchased by Garmin in 2006 and formed the ANT Alliance in 2007. The first million nodes for ANT were shipped in 2007. Till date, there's about 15 million nodes of ANT that are shipped, and they're shipping about 1 million nodes a month. ANT profiles. Unlike Bluetooth Low Energy, ANT being proprietary gives it the power to deliver profiles that are needed by ANT customers within weeks. ANT enjoys a very extensive set of profiles already available. These span from health and fitness related profiles to medical profiles. As you can see from the graphic, ANT has successfully deployed its nodes to satisfy most of the connected ecosystem for fitness and wellness. TI's ANT solution is a network processor. The ANT and ANT-FS stack are pre-integrated on the TI single-mode ANT device, namely the CC257X device. The applications will reside on the MCU. The CC257X is already pre-integrated with the MSP430. However, any MCU of choice could be used. ANT plus FS being integrated on the CC257X platform is unique in ANT silicon offering. This tremendously reduces your time to market and lowers the overall system cost compared to other ANT solutions in the marketplace. As mentioned earlier, ANT can support complex network topologies. Below is an illustration of the different network topologies that can be supported. Some of them include broadcast, peer-to-peer, star, a practical mesh, scanning modes, and shared clusters, etc. Current status and state of the union for ANT. ANT single-mode solution CC257X has been released to the market since second quarter of 2011. Samples, data sheets, development kits, etc. are all orderable on the web by going to www.ti.com/ANT. Similar to Bluetooth Low Energy, TI also develops a dual-mode ANT chips. These integrate Bluetooth plus ANT functionality in one chip. There are two offerings. The Y-Link series of chip, which are more suited for smartphones and integrate multiple technologies such as Bluetooth, Wi-Fi, GPS, FM, Bluetooth Low Energy, and ANT, and also a simple Bluetooth plus ANT chip called the 2567, suited for aggregation devices or tablets. All the above are available today, and they're all certified by Dynastream. A quick glance of the CC257X hardware. As discussed, it is offered as a network processor. The CC257X comes in two flavors, the CC2570, which is a 1-channel support, and CC2571, which is at 8-channel support. The 2557X chips comes in a 40-pin 6x6 QFN package, also supporting accurate RSSI for proximity pairing and TX support up to 4 dBm. A quick rundown on the features and benefits for the 2570. Extremely superior RF performance, up to 95 dB link budget. ANT-FS function pre-integrated on the CC257X device, leading to extremely low overall system cost and fast time to market. Over-the-air compatibility with all existing ANT products in the market today, as well as accurate full range RSSI functionality suited for accurate proximity pairing. The applications for ANT are also mobile phones, laptops, automobile accessories, sport, leisure, and medical equipment which have already been existing ANT, as well as proximity-based applications. The next slide shows a list of companies that have shown commitment to the ANT standard. These include Microsoft, Garmin, Sunto, Saris, A&D Medical, Adidas, Trek, Bosch, and more. Some of the proven ANT products in the market space that exist today are listed below. These include products in outdoor fitness market segments, indoor fitness such as gym equipment, bike power, bridges, as well as wellness and health. This slide shows you a picture of the CC257X development kit. This kit is extremely easy to use and has been extremely valuable to expand the ANT ecosystem. The kit includes 4 CC2571 8-channel modules, 2 battery boards, 2 EEPROM boards, 2 UIF sticks, and 2 coin cell batteries. For more information on samples and kits, please visit www.ti.com/ant or contact us directly at tiant@ti.com. That concludes the single mode ANT session. The next couple of slides do a very, very high level comparison of ANT versus Bluetooth Low Energy. Both ANT and Bluetooth are point to multipoint standards. Bluetooth Low Energy does enjoy Bluetooth 6 support, thereafter may have a wider deployment starting 2012. ANT provides immediate access to 15 million nodes of ANT sensors that are already in the market. ANT has been extremely focused on proximity and fitness-based applications and is extremely mature, stable protocol capable of supporting complex network topologies. The next couple slides do a comparison of the PHY layer and the MAC layer for ANT versus BLE. Some of the key differences are channel spacing for ANT is 1 MHz versus BLE is 2 MHz. The maximum power for both ANT and BLE is 10 dBm. The sensitivity for BLE link margin is expected to be 3 dB better due to the wider modulation index. A MAC layer comparison for ANT and BLE is listed below as well. From a topology standpoint, BLE is a pure star versus ANT being able to support complex network topologies such as mesh and star. The discovery device, slave channel scans, master channel transmits data for ANT, as opposed to BLE where the master channel scans and the slave advertises. This is defined per device. For more information on Bluetooth Low Energy, please go to www.ti.com/BLE. And there's also a link to go directly to the CC2540 page for samples, datasheets, dev kits, etc. For more information on ANT, please go to www.ti.com/ant. Below are also the links directly to the product folders for CC2570 as well as 71. And technical collateral can also be found directly at the Dynastream website at thisisant.com/ti/cc257x. Also listed is a link to the E2E portal community forum. This link takes you directly to the Bluetooth Low Energy and ANT E2E forum, which has discussions going on in the industry on these chips, as well as a lot of support questions and collaterals. That concludes the Bluetooth Low Energy and ANT session. Thank you.